Did you know that acid rain can change the pH of the soil and water in an ecosystem? It leaves behind many detrimental environmental consequences. This lesson is on the impacts of acid deposition. So, higher levels of sulfates and nitrates in rainwater lead to a higher concentration of hydronium ions in that water and therefore a lower pH. Typically, this deposition is affected by wind patterns, and it provides us with a way to trace pollution. So where was the pollution formed versus where was the acid deposited? Now, because Alberta's soil is slightly basic or alkaline, because of the carbonate caused by erosion from our limestone foundation, this typically will neutralize the acid deposition and limit the environmental effects that we see from acid deposition. So in this map of North America, we can see where the acid deposition has the greatest effect. And this is going to be in Ontario and Quebec. Again, they don't have a basic soil. And so those acid depositions are very serious to their environment. Now we can see that in the Chilean forest, the amount of precipitation derived is equal to the amount of precipitation derived elements leaving is those equal to those that are arriving. So nutrients arrive in the rain and leave through the soil through groundwater and streams. And so this is a system in balance. But when we have acid impacted forests, all the hydrogen ions that have been added to the soil replace an amount of essential nutrients such as potassium. So this causes nutrients to leave the soil at a greater rate than they are returned to the soil. So we end up with bleached trees because they don't have the nutrients necessary to successfully grow and photosynthesize. So when we have an acidic solution, one of the things we try and do is buffer it. So a buffer is used to resist the pH change in a soil or lake water. And so the buffering capacity is the ability of a substance to resist a change in pH. So if you add an acid, if that solution is able to neutralize it and maintain its optimal pH. So there are some plants that need to be in acidic soils, and other plants are very sensitive to acidic soils. And through biogeochemical cycles, different nutrients are deposited and they can be leached out of the soils or the water due to an increase in acid deposition. So for example, blueberries are an example of a plant that grows in acidic soils. And this is why you'll often see them growing underneath pine trees, because the decomposition of pine needles leads to slightly acidic soils, where the bleaching you see on the other side is what's common in other plants when the level of soil acidity gets too high. So plants typically absorb nutrients from the roots in the soil up to the leaves. And the process of acid deposition changes the nutrients that are available to plants because of the leaching that happens in the soil. Those hydrogen ions are replacing the nutrients. So once those nutrients aren't available, plants obviously can't use them. And then this nutrient deficiency causes the plants to die, become diseased, or weak. And so one of these is called chlorosis. And this is going to be a calcium deficiency, which causes a decreased production of chlorophyll in plants, which causes the leaves to appear yellow. So typically, a neutral pH is best for plants to grow. If those soils are too acidic or too basic, death will often result of your plant. So we can see here that lots of nutrients are available to at a neutral pH of 7. And there are some nutrients that are more readily available at a slightly acidic pH. And except for iron, once you get too acidic, even those nutrients start to become decreased in availability. And then some phosphorus even becomes more available once the soils are more basic. But a neutral pH is going to be optimal, or even slightly acidic, like 6 to 6.6 to 7 is going to be optimal for most plants to successfully absorb nutrients from the soil. So leaching is a process where the acid in the soil makes metal ions, aluminum and mercury, available to plants. And plants take these nutrients into their roots and then they dissolve in the soil or groundwater. So this affects the ecosystem because once those plants take the nutrients into their root, it decreases root growth and it also prevents the absorption of calcium. It's also going to reduce the decomposition of soil bacteria, it reduces the population of decomposing soil bacteria, which is going to reduce the amount of minerals available in a soil because those decomposing bacteria reduce life forms back down to their mineral and nutrient bases. Mercury, if it gets leached into the soil, also causes damage to the gills of aquatic animals, and methylmercury becomes trapped in body tissues, which leads to bioaccumulation. So bioaccumulation is when a pollutant increases in concentration up a food chain. So we might have a very low concentration of methylmercury in our producer population, so 0.04 parts per million, so very low concentration. But then at each level up the food chain, as the primary consumers eat lots of producers, their level of mercury in their body system will increase. Then as the secondary consumers consume the primary consumers, the level of mercury will increase again until tertiary consumers or quaternary have very high levels of mercury in their body system. And anything that eats those, which unfortunately often is humans, it can lead to some serious buildup in our body tissues. So for example, if a woman is pregnant, she's advised not to eat large carnivorous fish like pike from certain water bodies like the North Saskatchewan River because of the possible buildup of mercury in those systems. Small children are also advised not to eat too much tuna steaks because, again, when tuna fish are large and they're large enough to be put into tuna steaks as opposed to canned tuna, they can have to have larger levels of mercury in them, which can be toxic to developing cells. So this is an example of how abiotic factors in an ecosystem can affect the biotic factors. So acid rain is an abiotic factor. It's non-living, but it affects the biodiversity of the system by decreasing it because it changes the availability of nutrients in the soil, bacteria in the soil, the coating on the plants, and damaging aquatic ecosystems. So once that acid deposition changes the abiotic factors of the ecosystem, the biotic factors will suffer as a result.